Hello, my name is Louise Rogers and today I'm going to give an overarching view of the digital design tools that have been developed in the Transforming Timber project. This is the first episode of the Design Tools video series where I will run through what you can expect to find in the following videos. So the first output within this work package of the Transforming Timber project is a series of reports on design for manufacture, assembly and disassembly. The first report focuses on manufacturing, specifically discussing the adoption of a standardised kit of parts. Following on from this, the manufacturing process of the COP26 demonstrator has been outlined. This includes information on the principles adopted, such as the use of mass customisable systems, adopting standardised and repeatable components, as well as designing for ease of manufacture within achievable tolerances. The third and final report looks at designing for disassembly. This report takes the form of a case study which provides examples on past construction projects which have been designed in line with deconstruction principles, as well as providing recommendations on how future designs could be disassembled. In the next episode of this series, you can expect to find more information on the newly developed BIM design tool. In this tool, smart components have been developed to represent materials that have been utilised within the Transforming Timber project. These include cross-laminated timber, glue-laminated timber, and nail-laminated timber. This tool can be utilised in the design stage of a project where these components can be uniquely specified. Through a combination of user-specified and pre-existing data listed for the specific material and component types, quick analysis of the data output can be produced. As a result, this allows for quantity takeoff lists, environmental impact information, and connection types to be produced significantly faster than traditional approaches. For example, if we were wanting to determine the environmental impact of your design, you would be manually required to extract material volumes and global warming potential values for each design iteration, which is a time-intensive process that can be avoided through the use of this tool. The next video in the Digital Design Tool series looks at a code-compliant tool that has the ability to undertake structural checks in line with the required design checks for building warrant approval. This is the three-step process, starting with a 3D model that can be produced using the previously discussed BIM design tool. This BIM model is imported into Tekla Structural Designer, where the required load cases are applied. Tekla Structural Designer then generates the load paths in the form of a heat map, which allows the user to identify areas of highest stress. The results of the Tekla Structural Designer are then utilised in the second part of the design tool, which is in the form of an Excel document. This document allows the user to perform structural design checks and verify structural utilisation. This document can then be used as evidence for building warrant approval. So the final episode of this series gives an overview of the developed digital twin system for the Transforming Timber Living Labs. In this video, you will find further information on digital twinning, how it works, and what information can be extracted to influence future designs. In brief, the digital twin is formed of three elements: a physical entity, which in this case is a building, a virtual entity, which is the sensors which have been fitted into the building, and then finally the physical to virtual link, which feedbacks the live information. You can find more details on the digital twins and the Living Labs in the final episode of this series. So that concludes my introduction to the webinar series. You can find the links to the discussed documents and videos in the bio below.